video is on factoring an expression. Factoring requires you to rewrite this using the GCF as a factor. So first thing you're going to do, you're going to look at the terms. This is a 16 and we have a 40 here. What they have in common as a factor is 8. So I'm going to pull out an 8 as a factor, and I'm going to divide 16 by 8 and then 40 by 8. So what I did was I rewrote 16x minus 40 using 8 as a factor. And remember what a factor is. It's a number you use to multiply to get this expression. Now the nice thing about factoring is you can check. So if we use the distributive property like we did yesterday, 8 times 2x is 16x, and 8 times negative 5 is negative 40, and we get what we started with. So this is my final answer. Now I'm going to redo this same problem again. And let's say you picked the wrong GCF. Let's say instead of 8, you accidentally thought 4 was the greatest common factor. So let me show you what yours is going to look like. 16 divided by 4 is 4, and negative 40 divided by 4 is negative 10. This is not the same as this answer because this was not the greatest common factor. So what you need to do is you need to divide now by a 2. So now on the outside there's a 4 and there's a 2. So 4 divided by 2 is 2x, and negative 10 divided by 2 is negative 5. Then we have 4 and 2 as factors, which make 8. And now we have the factored expression. Okay, the next example we're going to talk about is if we have fractions to factor. So when you have fractions, the easiest way to figure out the common factor of 14/45 and 7/10 is to do the numerators together. So the greatest common factor of 14 and 7 is 7. Then we're going to do the denominators. The greatest common factor of 45 and 10 is 5. So the greatest common factor is 7/5. 14 divided by 7 is 2, and 45 divided by 7, or 5, is 9. 7 divided by 7 is 1, and 10 divided by 5 is 2. So this is my answer. And remember, you could check it by multiplying 7/5 to 2/9 and 7/5 to negative 1/2, and you will get the answer here in black. Now the third kind of problem that we're going to solve, it requires decimals. So let's say we had 2.5x plus 15. Now the ones that require the most practice, that are most difficult, are the ones with decimals. So what you're going to do, the easiest way to do this is ask yourself, if this was 25, what do 25 and 15 have in common? 5. So again, I'm going to pretend like there were no decimals. 25 divided by 5 is 5x. 15 divided by 5 is 3. Okay, now let's worry about the decimals. So what you're going to do is you're going to ask yourself, how many digits after the decimal? 1. Now the decimal on a whole number is always at the far right. How many numbers after the decimal here? There is none. So the greatest amount of digits after the decimal is 1. So we need to move this decimal on the 5, because remember a decimal is always at the right if there is not one. We're going to move it over 1, and now it is 0.5. How many numbers after the decimal here? 1, so we're good here. This one doesn't have one number after the decimal, so we need to add 1 0. Next, we need to ask ourselves, is there anything in common with 5 and 30? Yes, it's 5. So we're going to divide both of these by 5. So 5 divided by 5 is 1x, and 30 divided by 5 is 5. Now we're going to combine these together by multiplying. So 0.5 times 5, move the decimal over 1, we get 2.5 as our greatest common factor. So this is our answer. Now I want to do one more with decimals because I know those ones are the ones that are a little bit more tricky. So let's try 0.35x minus 2.8. So pretend like it was 35 and 28. The greatest common factor is 5. 35 divided by 5 is 7. Negative 28 divided by 5 is negative. Actually, this was 7. So take that out. So 35 divided by 7 is 5x. And negative 28 divided by 7 is negative 4. Okay. Then we ask ourselves, how many numbers after the decimal here? 2. How many numbers after the decimal here? 1. 2 is the most. So we're going to move this decimal twice to the left. So now it's 0.07. This number, does it have 2 after the decimal? Yes. So we're good. This only has one number after the decimal. We need it to be 2 like this one. So we're going to add 1 0 here for that number that's missing here. We're going to have to put a 0 here. So then we ask ourselves, is there anything in common with 5 and 40? 5. So 5 divided by 5 is 1x, and negative 40 divided by 5 is negative 8. So then we're going to multiply these together to get the GCF. So 0.07 times 5. Move the decimal twice, and we get 0.35. And that is our final answer. Now I think I'm going to do one last one. I'm going to do one more with decimals. Let's try 5x minus 3.5. So first thing, I'm going to pretend like that was 5 and 35. And they both have 5 in common. So 5 divided by 5 is 1x. Negative 35 divided by 5 is negative 7. Okay, now let's worry about the decimals. How many numbers after the decimal here? None. How many numbers after the decimal here? 1. So the greatest amount of numbers after the decimal is 1. So I need to move the decimal here once. So now it is 0.5. Does this have one number after the decimal? No. So I need to add 1 0 here. Now that's not 0x, because remember the number that was in front of x was 1. So if I add a 0 to 1, it's 10. And then over here, does this have one number after the decimal? Yes. So we're good. So then we ask ourselves, is there any number that can go into 10 and 7? No, so we are done. I think I want to do one more with decimals, just in case if you're like, okay, I think I got it, let me try one more. So let's say we had 1.5x plus 45. So first thing we ask ourselves is what can go into 15 and 45? 5. Now I could have picked 15, because I noticed now, oh, I could have picked 15 actually, but I'll worry about that later. So then I'm going to ask myself, how many decimals here? 1. How many decimals here? Numbers after the decimal here? None. So I'm going to have to move this decimal once. This one already has one number after the decimal, but this one doesn't, so I'm going to need to put a 0 here, because this didn't have any numbers after the decimal. So now I have 0.5 and 3x plus 90. But these have a common factor of 3. So I am going to divide out the 3. So now I have 0.5 in front and 3. So 3 divided by 3 is 1x, and 90 divided by 3 is 30. Now I'm going to multiply these two together. So I have 1.5 times x plus 30. And that is my final answer.